A car with weight 15,000 Newton is being towed up at 20 degrees slope at a constant velocity. Friction is negligible. The tow rope is rated 6,000 Newton maximum tension. Will it break? Good. Now, first of all, we need to identify what forces exert on this car. Okay, so look at the information. It has the, it has the weight. Okay, first of all, we look at it has the weight. Okay, so how to draw a weight? Let me just draw a weight over here. Okay, this is the weight directly downwards. Okay, it has the weight. 50,000 Newton. It's being towed up at 20 degrees slope. So this one should be 20 degree. The theta is 20 degree. At a constant velocity. This is important, this word. Constant velocity. Constant velocity. That means, what does it mean? What does it mean by constant velocity? Here it means. Still remember about the Newton first law? Newton first law, do you remember? Newton first law says that when velocity is constant, acceleration 0. Acceleration 0, that means total force equal to 0, which is Newton first law, which is equilibrium. Okay, so it's equilibrium for this case. So constant velocity, it implies that, okay, when velocity is constant, this implies acceleration 0, the total force equal to 0. Okay, total force equal to 0. That means total Fx is 0, total Fy also 0. In other words, this car is in equilibrium. This car is in equilibrium. Okay, because acceleration 0. Acceleration 0. Okay, it is equilibrium. Resultant force is 0. It's very important, this keyword, constant velocity. And then it's being towed up. It's being towed up, that means it must have tension. Okay, must have a chain or a rope to tow up the car. So it must have tension. Understand? Must have tension. Friction negligible. Friction negligible. So we can say is this surface is smooth. This surface is smooth because no friction. Surface is the friction is negligible. So friction is negligible. Friction is 0. Smooth. So the tow rope is 6,000 Newton maximum tension. Okay, well, now the tension is not 6,000 yet. It's not 6,000. You just say that the rope can withstand, the word withstand, can withstand a maximum tension of 6,000 Newton. Yeah, that means it can withstand maximum tension of 6,000 Newton. But the tension itself, so that means we say it has a tension here. It has a tension here, but it's not 6,000. It's not 6,000 yet. But we don't know. Maybe this tension is more than 6,000 or less than 6,000. We don't know yet. But it cannot stand more than 6,000. Yeah, so impossible that this tension can have a value more than 6,000. Okay, it just say this 6,000 is the maximum tension the rope can withstand. Okay, so this means that the rope not necessary 6,000 Newton. It's just that it can stand 6,000 maximum. Okay, so take note of this. Now, will it break? Will it break? So, to know that whether it can break or not, we need to investigate the value of tension. We need to investigate this value of tension to know whether it can break or not, because we need to investigate the value of tension. So then we can have a conclusion. Either the tension is less than 6,000, okay, So we need to know what is the value of tension. In other words, we need to know what's the value of the tension. Okay, we need to know the value of tension. It's not 6,000. Okay, we don't know yet the tension. We need to find out the tension. So to know whether it can break or not, we will have the two conclusion. Either the tension is less than 6,000, then cannot break. The rope cannot break. But if our tension is more than 6,000, it can break. Understand? If our tension more than the maximum tension it can stand, the rope can break. So we need to find out what is the value of tension. This is our objective. Yeah, this is our objective. We need to find out what is the tension. Okay, so just now we got the weight. We know the weight. It has a tension. This car is on the surface, isn't it? On the surface, that means it must have a. I should put this all into a blue, blue color. Okay, will be nice. Blue color will be nice. Okay. Yeah. So, okay. And another thing is this car is on a surface. On the surface, so that it must have a normal force. It must have a normal force perpendicular to the surface. 90 degree to the surface. What else? What else have? What else of? Okay, so that's it. Yeah, that's it. So remember the x. Let me draw the axis. The x-axis must be perpendicular to the surface. The x-axis must be the x-axis must be parallel to the surface like this. This is the x-axis, and then the y-axis must be perpendicular to the surface. Okay, perpendicular is not perpendicular enough. Yeah, my normal force is not perpendicular enough. Okay, but I will redraw. Yeah, and one more thing is this way is directly downward. Do you know that this angle is actually 20 degree. Okay, do you know that that angle is actually 20? Maybe let me draw it nicely for you. Okay, let me just rub it off. Okay, this is the weight. This is the weight. Okay, so do you know that this angle is also theta? Well, when this is theta, this is also theta. Okay, why? Why? Let me explain better. Let me explain deeper. Okay, let me explain to you this way. Okay, let me draw out for you. Okay, let me draw out for you first. Okay, I redraw the diagram for you here. All right, I redraw the diagram for you here, so it looks better this way. So this is the x-axis. Okay, x-axis is always parallel to the surface. Y-axis is always perpendicular to the surface. Perpendicular surface. You can tilt the you can tilt the x and y-axis. The x-axis is not always horizontal. Yeah, the x-axis you can tilt it so that it become parallel to the surface. Right. So now, Okay. Why do I say that? Why do I say that when this angle 20 degree over here, this angle here also will be 20 degree? Why I made such conclusion? Why? Okay, let me tell you. Yeah. Look at here. Look at here. You look at here. This one, this part, this over here. You look at here. Maybe this is not 90 degree enough. Yeah. Yeah, I think that's the best I can do. Okay. Look at this one. This is a right angle triangle, isn't it? Here this one is 90 degree. This is 90 degree, isn't it? Because this weight is directly downward. This weight is directly downward, and this line is horizontal. So this one is 90 degree. So what is this angle? What is this angle? What is this angle? Okay. Just make the line. This x-axis is parallel to the surface. Okay, this x-axis is parallel to the surface. So what is this angle? You can think that this is the right angle triangle with 90 degree over here. So what is this angle? This angle should be 90 minus 20. So this one should be 70 degree, isn't it? This angle should be 70 degree between the weight. You see, between the weight and the x-axis. Between the weight and the x-axis. So what do you think is this angle? What do you think is this angle? This angle is, look at here. This is the x-axis and this is the y-axis. X-axis and the y-axis, they are perpendicular to each other. So that means x-axis and the y-axis must be perpendicular to each other. So this is 90 degree. See that? This is 90 degree. So that means you want to get the green angle here. You want to get this angle. You need to use 90 degree minus the 70. So what is this angle? So what is this angle? So this angle become 20 degree. Do you see that? That's why this angle and this angle is equal. Okay, so when this is 20 degree, this angle also 20 degree. Yeah, the weight is 20 degree to the y-axis. Okay, this is the y-axis. The weight is 20 degree to the y-axis. How to get this 20 degree? Very simple. Because this is a right angle triangle, 90 degree over here. So you want to get this angle, you just take 90. Because this angle and this angle add up is equal to 90 degree. Because right angle triangle, here 90. So this angle plus this angle must be 90. So to get this angle, you use 90 minus 20, we get 70. 70, and then we know that between x and y-axis, they are perpendicular. Perpendicular, that means they are 90 degree to each other. So you want to get this angle, you just take 90 minus the 70. 90 minus 70, you get the 20 degree. So you get the 20 degree over here. So when this angle is 20, this angle also 20. You see that they are the same angle. So when this angle is theta, this angle also theta. Okay, good. That's the secret. Right? Just copy and just paste over here. Make another copy. So I want to simplify my diagram now. Don't want all these. Simplify it first. Okay, so I have simplified it. I created another two diagram. Okay, simplified version. And this is the free body diagram without the block. Yeah, free body diagram is actually without the block. You don't need to draw the block. You just draw a point to represent the block. Yeah, when the question asks you to draw a free body diagram, that means you need to draw a diagram without the block. Yeah, without the block, just a point. And the x-axis and y-axis, they are tilted. They are tilted according to the surface. Okay, x-axis must be parallel to the surface. When the surface is inclined, your x-axis need to be inclined also. Yeah, need to be inclined also. And y-axis must be perpendicular to the surface. Okay, this is the free body diagram. Now, so we never mind. We can use which one? Maybe we can use this one also. Okay. So we want to investigate what's the tension. If it is less than 6,000, that means the string cannot break. If it is more than 6,000, surely can break. So first of all, friction is negligible. It's constant velocity. Yeah, use the concept of equilibrium. Total force equal to 0. Okay. Total force equal to 0. That means total Fx equal to 0, Fy equal to 0. Okay. So using this one, this currently is a constant velocity. So constant, just write acceleration 0, yeah, because velocity is constant. Okay, right now velocity is constant, acceleration 0. Never mind for a second. Yeah. So you just write here this direction of the velocity, the direction of velocity, but this velocity is constant. Okay, this direction of velocity is constant because acceleration 0. Okay, no friction, yeah, because it says smooth, friction is negligible. So just these three forces. So equilibrium, total F equal to 0, Fx 0, Fy 0. So we need to do two components. One for X, one for Y. Okay. So first of all, we already know that the first condition is the total Fx equal to 0 and total Fy equal to 0. Okay. Total Fx equal to 0, right? Total Fx is 0, total Fy is 0. So, okay. We first of all, the sign convention, when equilibrium, for equilibrium, we take going to the right is positive, going to the left is negative. This is to the right is positive, to the left is negative, going upward is positive, downward is negative. Because acceleration 0, we don't have an acceleration to compare. Yeah, we don't have acceleration direction to compare. So we just put going to the right positive, going left negative, going up positive, going down negative. That's the positive negative sign for the force. Next is we resolve the vector. We resolve the vector if they have angles. Like tension and the normal force, no need to resolve because they already tension is already totally x component, normal force is totally y component. But the weight has two components. It has x component and y component. So we need to resolve that. Okay, so resolve it first. So we resolve it. Okay, resolve it. So this is the x component and this is the y component. Okay, so what's the x component for the weight? The x component for the weight is actually, so this component is actually opposite the angle, isn't it? It's opposite the angle, so it is w sine 20, w sine 20 because it's opposite the angle, And how about this y component? This y component is adjacent to angle. You see that? This component is adjacent to angle. Adjacent to angle, you must put w cosine 20. Okay? So this component is adjacent to angle, so it's cosine. This component is opposite to this angle. Okay, opposite to this angle, so use sine 20. Okay, so we already have all the x component and y components. So now let's start off with x component. X component, equilibrium. This is about equilibrium. That's why total Fx 0, total Fy 0. Yeah. Why equilibrium? Because velocity constant. Yeah, it did mention constant velocity. So now, okay, so look at x component first. X component, we have what force? X component, we have tension and w sine 20. Tension is positive. W sine 20 is negative. So write the positive negative accordingly. So tension is positive. So put as positive tension, and then the weight sine 20. Weight sine 20 is negative. So put negative. Okay, negative. Weight sine 20. Weight sine 20. Okay. All right, that's it. And then do we have other forces? No more. We only have these two. So these two only. And then these two, they are equal to 0. They're equal to 0 because the resultant in Fx is 0. Okay. How about the y components? Y components, we have what? We have the normal force, positive. and then we have W's cos 20 as negative. So we put it as a positive normal, and then we have a negative weight. You see, we have negative weight. So write it down. We have negative weight cos 20. Okay. So we already have positive n. We have positive n. Okay, we have positive n. We have positive n, and also negative w. We have positive n and negative w cos 20. Okay, so that's it for y components. So we got it already. So now, what else we need to do? We need to find the tension. Oh, which component can find us the tension? This one can only find us the normal force. You see that? This one is equal to n equal to, okay, w, negative w cos 20, go to the other side, become w is mg cos mg cos 20, and then this one is tension equal to w is mg, also mg sine 20. Which one can find us the tension? Of course, the x component. So actually, y component you no need to do. Y component no need to do. No need. Yeah. Unnecessary. This one unnecessary to do. Sorry, my spelling. Yeah. Unnecessary to do, unless, okay, unless we need to find friction. Unless have friction. Unless if we have friction, then we need to, like, because the friction formula, it has a Fs equal to, or we can say F, let's say kinetic friction. Kinetic friction, it has a mu kn, isn't it? Mu kn. It has the friction. Yeah, if we have in x component, if we have a friction, normally friction occurs in the x component. Okay, normally occurs, it doesn't occur in the y component. Okay, it doesn't occur in the y component. Normally friction occurs in x component. Then friction will use the formula of mu kn, isn't it? We need to find the normal force. You see, we need to find normal force. Then only we need to refer to y components. Because the normal force, to find this normal force for the friction, you need to refer to y component, because the normal force here is only in the y components. The y components, we have mg cos 20. Yeah. Then we need the y components to find the normal force. Then after we get the value of normal force, we can substitute into the normal force here to find the value of friction, then to be used in the x component. Understand? If if the condition is the surface is rough lah. If the surface is rough, then the x component have friction. To want to find friction, we use the formula mu kn. Okay, since the formula have the normal force, we need to refer to y component to find the value of normal force. Then only we can substitute into normal force here to find the value of friction to be used in the x component. Understand? Okay, right now is our surface is smooth. So our mind also smooth lah. No need to worry so much. Yeah. So we no need to find friction. No need to find friction for this question. So we no need to find normal force. We no need to find no force. So no need to do the y components. We just do the x component enough. X component alone can find the tension already. You see, tension equal to mg sine 20. Just that simple. So tension equal to mg sine 20. M is equal to, what's the mass? Oh, this give the weight. Yes, look at carefully. This is weight, not kilogram, not kilogram. This is not about mass. This is not about mass. This is not about mass. This is about the weight directly. So this is already mg. So mg is equal to, okay, mg is equal to mg. The weight is equal to 1,500 Newton. This is already mg, the whole thing. Understand? This whole thing is already mg. So okay, so just substitute. No need to multiply g anymore. No need to multiply g. The whole thing is already the weight. Sine 20. So what's the answer? What's the answer for the tension? Okay, what's the answer for the tension? Sine 20. Okay, so that's the 5130. So it's a 5130.3 Newton. Oh, okay, so it is less than 6,000. So we got the tension less than 6,000, less than the maximum tension, which is the 6,000 Newton. So can it break or cannot break? Will this string break or cannot break? This tension is only this tension we got is only 5130.3, less than 6,000, less than the threshold value. So it cannot break. The string, the rope cannot. Maybe I should write down. Hold on a second. So we got the value less than 6,000. So we say rope cannot break. Rope cannot break. Remember, you must write to compare with the 6,000. Now you must write this symbol, less than. You must write less than 6,000 Newton. Because this is answer for explanation. Answer for explanation. You cannot just say answer cannot break. Cannot break and then without any proof. No, you must prove by calculation. Prove by calculation. Because got marks. Okay. Cannot just say cannot break without any evidence. No. Yeah. What we say must have evidence. So this is our evidence. Less than 6,000. Okay. So the rope cannot break. Okay. So that's it for will it break? So the rope cannot break. Cannot break. Yeah. So it's good. Though, so the car, we can say the car is safe. The rope cannot break. That means car is towed. Car is towed safely. Car is towed safely. Okay, up the inclined plane. Okay. Okay, that's it. Thank you.